Therefore, in the 3D graphics, theory part actually, smaller theory part will be covered, practical part will be covered in a more manner. We are going to use some application environments to do the 3D computer graphics, right? So therefore, this 2D and 3D graphics, in 2D graphics part, I'm going to do most theory, but again, to cover up and refresh your knowledge about 2D graphic applications, I'm going to show you some of the things which we can perform and refresh your knowledge with CorelDRAW to cover the vector graphics and Photoshop to cover raster graphics. We are going to do few sessions we are going to cover under 2D graphics. When we come to the 3D graphics, the theoretical part will be covered, but that is more mathematical subject. Therefore, we are going to do more practicals on 3D graphics with 3D Studio Max. Okay, in the level semester one, you have done mathematics, IIT, right? Mathematics for IT. Am I correct? Yes or no?
Yes, sir.
In level one, mathematics for IT, you may have learned matrices, right? Am I correct?
Yes, sir.
Okay, most of the mathematical things you have learned within level one, including matrices. So the main thing is matrices. We are going to apply in 2D and 3D graphics, theoretical part, right? And algorithms design. So other than that, we are going to learn now in the Photoshop and CorelDRAW. In Photoshop and CorelDRAW, you may have applied different tools, right? Different tools like filling tools, line drawing tools, right? So those type of tools and how those tools work also, we are going to learn uh, more scientific manner. Their algorithms are going to be there. That means what type of programs are behind. මොන වගේ programs ද මේවා ඒ tools වල ඇතුලේ ක්‍රියාත්මක වෙන්නේ. ඒ වගේ දේවල් කතා කරන්න බලාපොරොත්තු වෙනවා. So those are the things we are going to discuss broadly in 2D and 3D graphics. Okay, let's see what are the things we are going to cover here. Today I'm going to do only the introduction part. So today I'm going to take this introduction to computer graphics, and then the next day we will be able to discuss about graphic devices and the uses of those devices. Different type of devices are there. Categorically, we can categorize them into different groups. So then we are going to discuss about 2D graphic concepts, 2D graphic concepts and 2D graphic algorithms also we are going to discuss. 2D graphic algorithms, 2D graphic concepts and 2D graphic algorithms we are going to discuss. And then we are going to discuss about graphic animations, right? Graphical animations. And 3D computer graphic concepts are also to be learned here. 3D computer graphic concepts. 3D graphic algorithms are to be learned. And 3D animations. And those are mostly we are going to cover 3D graphic representation and 3D graphic, little bit of algorithms we are going to learn, but 3D animations we are going to discuss and we are going to do it. And the use of graphical packages, mainly the 3D graphic packages will be discussed here. And if we have some extra time, we will be able to do the graphic programming. Now, for this particular subject, you have to know there are two components available, practical component and theoretical component. Under the theoretical component, we are giving final examination paper. So there are two assignments available for you. Those are assessment, continuous assessment. Those are practical assessment. We'll see how to do that practical assessment also. Normally, when I was doing this thing face-to-face sessions, on the spot practical assessments were done. But in this case, we are doing this distance mode over this Zoom. Therefore, there is a problem of conducting it in that manner. But anyhow, we'll see how to do that, those type of practical aspects. Mainly those are coming from 3D graphics. So there is nothing coming from the 2D graphics applications, right? And when you go to the final examination also, you have the practical component as well as theoretical component. Both are there. and I will show you what type of thing you are going to do there as well. Okay? So, right. Let me show you one of the example at the end, the practical, what type of thing you have to do. I'll normally show that one also, most of the situation at the beginning, then you will have some kind of understanding and target. What are you going to do? I think you can see my screen now, right? Yeah, you will be
Yes,
doing
sir.
this type of examples. You will be able to do this stuff. Right? These are very small animations. That is one example for what we are going to do at the end in the examination within maybe 1 hour period. You have to do that type of animation. So that is the practical part. Right. So with that, again, I'll go to back to my slide set. So these are the things we are going to cover. If you have any questions about the things what we are going to do and cover, you can ask now. Is there any question? Seems there are no questions. Let's move forward. Now let's see what is computer graphic. Now we know normal graphics, right? We have done in the kindergarten or in the preliminary studies. You may have already done how to draw things, how to paint things, how to illustrate things. You have already done those things, right? You have already done those things, right? So when you are doing those things, you have done those things on the real environment and you have created these graphics. Okay. When you are drawing things, right, in the drawing book or whatever the place, what type of things you have done actually? What is the thing you did in the drawing? What did you do in the drawings or the painting? මොනවද ඔයගොල්ලන් පේන්ට් කරලා මොකක් හරි ආර්ට් වර්ක් එකක් හදනකොට කරේ මොකද්ද? ඒකෙන් බලාපොරොත්තු වෙන්නේ මොකද්ද?
A visual display.
Visual display. You have expected visual display. How do you now that visual display is coming from somewhere? So how do you decide what the visual display and those things?
Some message.
Yes, message. You want to communicate some message. Yes, that's good. You have to do the communication of a message to one part to another part. But from now the message is available within the graphic, right? Or the artwork. Huh?
Yes, sir.
How do you how that particular thing you create actually? It's a painting or anything. From where that particular thing comes? කොහෙන්ද ඒක එන්නේ?
නිර්මාණශීලී කියන්නේ creativity.
Creativity of whom?
From the skill and knowledge.
Skill.
From the skill and knowledge of a person, right? Now, person from the person, how that particular person put this thing into the paper or some kind of artwork. That creativity is coming, but creativity needs something, right? Most of the time, the people take things from the real world. අපි දකින දේවල් වෙන්න පුළුවන්, අපිට දැකලා තියෙන දේවල් වෙන්න පුළුවන්. ඒකම තව එකක් තමයි imaginations. Creativity and imaginations. මනක්කල්පිත දේවල් ඔය එක එක දේවල් ඔය හදන්නේ කා එකක් වෙන්න පුළුවන් අමුතු විදියට. That is artwork. That is a creative work. That is what we call as creative design. Creative design. You are coming with a model of real world thing most of the time. Computer graphics normally takes a model of a world, model of a real world, and generate an image. It will generate an image and manipulate the way you want. In the computer graphics, what you do is you take some kind of a concept. Suppose you want to create an elephant. You draw an elephant. mango කියන්නේ අඹ ගෙඩියක් තියෙන එක. දැකලා තියෙන දෙයක්. ස්වාභාවිකව තියෙන දෙයක්. So you take that mango concept and put it into a computer. So the graphic can also be used for visualizing to visualize a data set. Visualize a data set. And you can take the real world things as well as you can take imaginary things. And you can put forward them to represent ideas, right? To represent ideas. Now, when we look at the computer graphic application, so in the computer graphic applications, that may be information systems, computer design, geography information system, GIS, scientific visualization, entertainment, education, virtual reality, film, video creation. So these type of applications can be created. These are the areas of applications. Now, when we look at the basics of computer graphics, now computer graphics can be divided into two parts. Now look at these two images, right? Can you see two images on the screen? Images they are paying.
Yes, sir.
Right hand side, what type of thing is there? And left hand side, what's the difference between these two?
It's the right hand picture, more details in this picture.
Yes.
Left hand side picture, only circle, only. Simple, very simple.
Simple circle is there. It is simple image and you have only two colors, right?
Yeah.
Detail, how do you get details here? Why there are no much detail here? How do you get these details here? How do you see those details here? Okay, tell me what are the details available here?
Sun, sky, and some trees.
You can
Sunshine.
see tree, you can see sun, you can see sky also. What else?
Sunshine.
Sunshine is there.
Some trees.
Yeah, that is a sunset, right? In the other way, sunset or sunrise. Sunset or sunrise. Those are the details. You have such details. How that details comes to you? Those are from colors, right?
Yeah.
කොහොමද ඔයා කොළ තියනවා කියලා ගස් තියනවා කියලා දැක්කේ? මේකේ තියෙන effects එකේ shapes උයි colors උයි. You just take the shapes and colors. Okay?
Yes, sir.
You just grab the shapes of the image and the colors of the image. Then you interpret and details are coming from your brain. Details are coming from your brain. Now, when you look at this one, do you have such details? No, only two colors. So there are more colors in the complex images. So detailed images, you have more colors. Simple images, you don't have such more colors. Simple images, you have very simple color representation, maybe doing something like that. Okay?
Okay, sir.
Now here also you can see the videos and movies that is computer graphics are overly applied. And here you can see a scene from Jurassic Park type of thing, right? The three-dimensional creatures are available, right? Dinosaurs. And here you can see 3D games. In 3D games, OMD use these computer graphics effects and you can have virtual environments and medical imaging for diagnosis, this type of the scanned images. You get body parts and internal parts represented in on the computer graphics. Now, let me come to some of the applications what we have discussed here. Computer design. Now, this one is a computer design. The wire mesh is there, 3D graphic. We can create a structure and the surfaces of this type of object. And we can represent the structure of a particular object and see how it fits. And we can simulate how it react on particular some kind of a maybe resistors. In presence of resistors, how it will react, we can identify. So this is a wireframe representation. So normally graphics design packages provide standard shapes and we can repeat them in this placement. And animations are also used in computer-aided design applications. CAD stands for computer-aided design application. And realistic displays of architectural design permits a simulated walk through rooms. Virtual reality systems are also possible. Now, this type of machine design or model design also are possible by using computer-aided design packages, 3D design packages. Architectural designs are there, home designs are there, like that you can see before building it, before constructing it, you can see the same thing as a model. So those are coming through computer-aided designing, those are computer graphics things. Presentation graphics, like here you are looking at a presentation like bar charts, line graph, and these type of presentation slides. Here you have those examples. Right. Graphical statistical representations are there. Computer art used fine art and commercial arts to to represent creative ideas, cartoon drawing, paintings, and different paintings what you have done by using the sheet of paper and the paint brushes. Nowadays, all the paintbrush things can be applied in the computer environment. You may have already seen that vacuum devices, type of devices are there where you can draw on the computer screen. And you can create that graphic with the colors and everything. When we look at the examples, here we can see 3D graphic suitcases, atmospheric effects like this mist, and water. All these things can be created by using computer graphics. And these type of cartoons are also possible, shadows and everything. So in the computer art, actually what we are going to have is, it's an electronic painting, not real paints. You don't have real paints there. Now, in the painting, what we do? අපි කොහොමද painting එකක් අඳින්නේ? මොනවද අපි painting එකේ තියෙන්නේ අන්තිමට? අපි අදහස් yeah, art represent the concepts, objects and all these things on the screen, not the screen, on the painting paper. On the paper, what do you get? අර කොලේ මොනවද තියෙන්නේ? ඔයාලා ආර්ට් එකක් හදන්නේ මොනවයින්ද? දැන් white කොලයක් තිබුණොත් ඒකේ ආර්ට් එකක් වෙන්නේ නැහනේ. white කොලේ ආර්ට් එකක් වෙන්නේ කොහොමද? ink or the colors. Here you can see different colors and they are grouping and representation of their shapes with the color gives the meaning. අපිට අදහස එන්නේ ඒ colors වලින්. ඒ colors වල නිරූපණය. ඒ colors හරියට හරි විදිහට තිබුණොත් තමයි අපිට ඒ අදහස, ඒ මූර්තිය, ඒ කියන සංකල්ප ටික අපේ ඔළුවට එන්නේ. So therefore you have to understand computer arts or computer graphic is about representing colors with respect to the meaningful manner, according to meaningful manner, the way the audience wants. Computer graphics is all about representing colors, meaningful manner, the way you want. In electronic painting, so the picture painted electronically on graphic tablet, like digitizer or maybe vacuum device using stylus, you can draw it. And there are different painting brushes also nowadays available. Codeless pressure sensitive styluses are there, you can draw things. Morphing type of effects can be done where you can one object transform into another object, shape transform type of things are happening. And the graphical transformation, for example, you may have seen that the Barack Obama transformed into Bill Darden or the George Bush transformed to Bill Darden graphically. So those are morphing effects. Those things we call as morphing effects. Here you have one example for a morphing effect. In morphing effect, you can see there's a kind of a reptile here, reptile like chameleon, and there's a girl, and we give the shapes and map those shapes here and here, draw those shapes and here. And finally, you can create a video that this girl slide very smoothly becoming that particular reptile. So these type of things are possible. Normally we call that as morphing effects. In the entertainment industry, heavily these computer graphics are used. For example, these type of movie creation and like Titanic type of films, and also here these type of cartoons. Now cartoon industry is booming marvelously. So movie industry use these motion pictures and graphic creations are heavily used. If you think about that recently ended Game of Thrones, that all the that particular dragons and the going on dragons wars all are computer graphic effects. Normally we call that now there's a new terminology used for that one, computer imagery, CI tools are there. Here you have the computer graphic animation, 3D graphics, and here we have another movie from Jurassic Park. We have already seen that one. And here we have that game industry, 2D games, 3D games, all these type of games are there. Where people can manipulate these type of 3D objects and rotation, scaling and movements and everything can be done. And in the virtual environments, you can walk and fly and do different items. So all these facilities are facilitated by using these computer graphics called 3D computer graphics. And apart from that, educational and training, there are so many computer graphical applications are available to simulate actual things, right? Simulate actual things. The simulations are not real, but actual environment can be created by using these simulations. What type of simulations are these? Actually, for example, you want to train a pilot. When you want to train a pilot, giving a kind of a flying system directly is a kind of a risk. So before putting him to the cockpit, what we can do is, because if something goes wrong, he will die and the whole thing collapse. So therefore, before putting him into some kind of a cockpit or some kind of a airplane, what we do is normally we put him into a virtual environment with a kind of a cockpit, all the buttons and everything available. He will feel that he is flying, and all the environment is like flying, and you get the necessary dynamics, and then you will feel that one, and you can control a real type of cockpit. And here, virtual driving cars are there. This is an example for that virtual driving car, where you will drive, and the driving games are also there. Air pilot, here air pilot, heavy equipment operators, air traffic control personnel, you can train them in virtual environments by using graphical systems. Here training in flying systems. And this is also in the medical field also, these are applied. Now we know that cataract surgeries, right? And eye surgeries. It's very risky thing for giving your eye to a apprentice or trainee. කවුරුත් කැමති නෑනේ ට්‍රේනි කෙනෙකුට තමන්ගේ ඇහැ දෙන්න ඔපරේට් කරන්න. පළවෙනි වතාවට ඒ වගේ එකක් කරන කෙනෙකුට හැක් දෙන්න කැමතිද? පොඩ්ඩක් එහෙම වුණොත් you are getting into the blindness. Therefore, what we do is actually we train these type of doctors beforehand with these type of stimulation environments. So they will be given some kind of a stick, and that training will be given how to handle that stick and do cataract surgeries and all. Once you learn those things, then you can go for real surgeries. Now, when you are doing any mistake in these type of systems, it will indicate you are doing something harder, you are softer manner. So those type of things are all very calibrated, and very easily you can get your hand trained with these type of systems. And the other thing is visualization, scientific visualization, producing graphical representation for scientific, engineering, and medical data sets. And here you have radar data type of thing. Radar data is a graphical representation of some kind of a aerial data with the representation of objects. And here scientific visualization available for some of the molecular structure. So these are not real. From naked eye you cannot see, but you can construct some kind of a model and see. මේක අර දැලිස වගේ දැලිස කරලා තියෙනව නේද අර atomic structure එකේ අර ඒ වගේ දේවල් අපිට පෙන්නන. And there are some other applications like business visualization, and also industrial visualization. All these things, all these places you can use graphs, charts, and all these things with the necessary graphics. Now, there's another area, very important area, called image processing. If you come to Photoshop type of application, Photoshop type of application is full of raster graphic processing tools, raster graphic processing tools. Those are normally called as image processing tools. Raster graphic processing tools are normally get with image processing tools. These image processing tools are coming with different elements and buttons and all. These tools normally represent different aspects in the operations. Like you can select areas, you can recolor, you can fill the areas, and you can select some kind of pixels with colors, and you can give the shadow effects and maybe texture effects. Different image processing things can be done. You can transform into gray level to colors to gray. Color transformations are also possible. So here image processing, normally picture enhancement can be done, enhancing the images. Unclear images can be enhanced. Noisy images you can clean. And medical images you can improve. You can create simulations. So those type of image processing applications are also available under the computer graphics. But here in the computer graphics, we have already separated in your curricula. In the computer graphics, we are only focusing on the graphical creation. Processing things will be discussed later as a separate subject next semester. Right? That is the digital signal processing and image processing subject. So by application of image processing, you can improve the picture quality and machine perception of visual information. Robotics type of things also can be done. To apply image processing methods, for example, digitize a photograph into an image file and apply digital methods to rearrange picture parts to enhance color separation, improve quality shading, tomography techniques of X-ray photography, as you can get the cross-sectional views and the more details of the body part. X-ray tomography, CT scan, PET scan, position emission tomography, right? The PET scan. There are so many those such medical equipments using these computer graphics things and the image processing things. Okay. Here we have 3D structures and 3D structural representations of 3D structural representation of different objects. Brain representation is there, and your backbone representation is there, and tomography representations are there. 3D and 2D both can be applied in medical domain. So those are some examples from them. And graphical user interfaces like web and application developments, normal application development and graphical application interfaces are there for the inputs of different applications. All these things are coming under that category. Now here we have buttons, libraries, and all these things together. And so there are some graphical packages available, a set of libraries that provide programmatically access to some kind of graphics 2D functions, like graphic kernel systems and programmers PICs and Silicon graphic libraries there. So these are some programming libraries are available. And these are giving necessary tools for programming the graphical environment. Now, by using, for example, OpenGL, all these things are available within most of the graphical packages as a supporting libraries. මොකද මේවයින් තමයි අර graphical packages හදලා තියෙන්නේ. Photoshop ගත්තත් 3D Max ගත්තත් Maya ගත්තත් ඒවා යට තියෙන්නේ මෙන්න මේ libraries. මේ libraries වලින් තමයි methods ඒවට අවශ්‍ය මූල components, right? Foundation components are given from these libraries. Right. With that, we are coming to a kind of a juncture that let's see this type of thing, 3D cube. And when we look at the graphics, we see that as 2D. Now let's see what I'm talking. Now here, when you look at 3D, you see my face as a 3D face, right? 3D face. Yes or no?
Yes, sir.
You see my face as a 3D face. But that 3D face or 3D graphic is, when you look at 3D graphics, the third dimension you can see normally. Third dimension means, what are these dimensions? Width, height, and height, and depth. The third dimension. Third dimension එක කියන්නේ ඒක ගැඹුර. පළල, දිග සහ පළල සහ ගැඹුර. Those are the three dimensions. Right? You see there those three dimensions of the computer system. But when you look at this, three-dimensional representation, actually that three-dimensional representation is happening or available. This three-dimensional representation is happening or available on two-dimensional screen. That is available in 2D screen. Right? That is available only on two-dimensional screen. And on the two-dimensional screen, you are getting this 3D. So there is no 3D on your screen. Even though there is 3D, you do 3D, there is no 3D on your screen. තුන්වෙනි අර අපිට අත දාලා බලන්න බෑනේ ඒක අල්ලන්න බෑනේ. So මේ 2D screen එකේ තමයි පෙන්නන්නේ. So we are tricking your eye. We will see that 3D, but we are tricking your eye by this particular screen, by showing the third dimension, which is not available on this particular screen, by illusion. ඔගලන් අපි ට්‍රික් කරනවා, කවුරුත් ට්‍රික් වෙනවා, මනුස්සය දකින මනුස්සය ට්‍රික් කරනවා. ඒ කියන්නේ එහෙම එකක් නෑ. නිකන් මැජික් එකක් වගේ තුන්වෙනි අවකාශය වෙන්න. මොකද එහෙම එකක් නෑ. That third dimension will be created by our brain when we see on the screen. Actually, screen is 2D, not 3D. We see 3D. Later we will discuss when we go to the 3D graphics further. So when you are producing picture, actually, suppose there's a person here. We see this person, like we see this person by using this picture. Like we see this person by using this picture. We are creating some kind of light rays. We are creating light rays. It's a real life picture. We are creating light rays. Those light rays comes and incident on this particular person, right? The light rays comes and incident on this particular person, and reflected rays are coming to the camera. Incident rays and reflected rays are coming to the camera. And finally, these incident rays and reflected rays are coming to the camera from this person's reflected rays. The reflected rays are generated by this person, and incident rays are generated by this some kind of a light source, and these reflected rays are captured by this camera, and those are coming to the screen. That's what we see. මේ ආලෝක කදම්බ වලින් තමයි මේකේ රිෆ්ලෙක්ට් වෙලා එන ඒවා තමයි මෙතනදී ගන්න. ඒවා තමයි අපි රෙජිස්ටර් කරලා මෙතන පික්චර් එකක් හැටියට ගන්න. So therefore, when the reflected rays are coming, they are carrying the colors. They are carrying colors. Those colors are the things you are capturing here. When we go to the image processing, you will see how the camera capturing works. Then you will better understand these things at that level. Normally in computer graphics, these type of three-dimensional surfaces will be represented. You will see them as third dimension. Depth information also you get. You see that there are circulate areas and the depth information. Actually, those are illustrated and giving you a kind of illusion of third dimension. Actually, there's no third dimension. It's a picture. Computer screen එකේ පේන්නේ picture එක. Third dimension is not there. But in computer graphics, we can give the realistic effects of all these things like shininess, dimensions, and their smoothness. Everything can be given nicely. Right. So that is the point I want to stop here today. And I told you I'm going to take only 1 hour session today. And next day we are going to start with graphic devices like hardware devices and their categories. Normally these computer hardware and normally graphic system can be divided into 2 categories. The graphic full system can be divided into 2 categories. One is computer graphic hardware. The other one is computer graphic software. So both computer hardware, computer graphic hardware and computer graphic software available. In computer graphic hardware, those are supporting to produce and display computer graphics. Software generate necessary algorithms and calculations are done to generate and give the illusion of effects what we want. So therefore, this combination of hardware and software produce graphics. So there are some applications which are running as application software. So next day we are going to discuss about what type of hardware are available, what type of software are available, and what type of hardware categories are available. Next day we can see. right? So next day I'm going to start from here, that is basic graphic system. In the basic graphic system, you can see these type of input devices, processing devices, and display devices. And the processing device normally supported by this type of memory, and memory is going to be used to store the data and necessary uh, information for representation of the graphics. Let's discuss about these things next day in detail with these computer graphics elements. Right. With that, if you have any questions up to now, I would like to take them. Otherwise, we can wind up today's session. Today, we have discussed the introduction to computer graphics, and we discussed what type of things we are going to do in our today the full session from today onwards. And I told you that there are some practical sessions also available. In 2D graphic practicals, I'm not going to do much, but I'm going to cover a little bit of maybe refreshing your knowledge about raster graphics with Adobe Photoshop and vector graphics with sometimes in when you are doing your diploma, you may have done Illustrator for the vector graphics, right? Are there any people who have done Illustrator? Adobe Illustrator?
Yes, sir.
Okay, some people have done Illustrator, some people have done CorelDRAW. So therefore, here we are going to discuss vector graphic concepts by using CorelDRAW and raster graphic concepts by using Photoshop, right? So most of you have done Photoshop, therefore very easily we can do those things, and very few examples we are going to do here. But when we go to the 3D graphics, we are going to more focus on our application application assessment also. So those are the things I'm going to discuss for today's session. And any other questions? Any questions? Okay, then I'll stop here for today's session. Next day, again, yes, there's a one. Okay, let's see. One is asking what is frame buffer. I'm going to talk about this frame buffer next time also. Just as that person having some kind of a curiosity about this one, let me tell you what is frame buffer. The frame buffer is a kind of a, when you are creating one screen here, right, you can see one screen. That screen got a lot of, normally this particular screen, computer graphics screen consists of many pixels, data or colors. Those colors are available, color dots. Think that manner. There are many color dots are available. Those color dots are representing a color. Those color dots are representing color. Now, color is stored as a memory data or data. Varnaya datta hatiyata koyada tiyena. So for each and every picture what you see on the screen at a particular time, each and every picture what you see on the screen at a particular time is stored in a special memory called frame buffer. For each and every time when the screen changes, frame buffer also changes. First, frame buffer changes what is the memory or data available for the screen. That data will be put onto the screen. Do you understand? For the time being, understand that way. Is that clear?
Yes.
Sandamali? Sandamali? Okay. So there's another question, sir. What type of software installed in 3D Max version of our PC? Okay. What is the version you want? Okay. You can install 3D Max version 16 or above, right? Version 16 or above. 3D Studio Max version 16 or above. 64 bits version එක දාගන්න, right? Shehan?
Thank you, sir.
Okay.
Thank you, sir. Okay.
So with that, I will stop here today and we'll meet again next week, right? I don't know when we can start face-to-face session. It's very hard to do this particular type of course online. But for I don't know what to do with this particular situation. Anyhow, we have to do. We'll see our best to do this thing online, right? Okay.
Okay, sir. Yes, sir.
Okay.
Okay, sir.
Thank you, sir. Okay.
Okay. Right. Good night.
Good night, sir.
Good night, sir.
Nice.